So to calculate the force at 0, 1 meter, r12 is still 1 meter, right? But it's times j now. You know, your vector from here to here is going to be 1 meter times j, right? Okay? And r is still 1 meter, as we say. So that the denominator is going to still be the same as it was here. And your unit vector is going to be j. So it's very clear that this is going to come out with the same magnitude this one did, but times the j vector. And it should be no surprise that we get the same magnitude because we're at the same distance from the same charge, and our charge is of the same magnitude. Our moving charge just moves over to here. Well, okay? So that should be very clear. Now here, I'm going to note that this entire calculation, I believe, gives us (9 times 10 to the negative 4th Newton meter squared, right? And you'll be dividing that by your distance from the origin out to xy, wherever xy might be. Well, x units in the x direction, y units in the y direction. Your hypotenuse will be the square root of x squared plus y squared. So that's the square root of x squared plus y squared. That gives you x squared plus y squared. And then it's times your r12 vector, which is from here to wherever this charge is. That vector is xi plus yj, and then that's divided by the magnitude of this vector, which is the square root of x squared plus y squared, and that is your, in this case, 9 times 10 to the negative 4th Newton meter squared over x squared plus y squared to the 3/2 multiplied by xi plus yj. So wherever xy is, the force is going to be parallel to xi plus yj, which is just this vector. Okay? And for these two charges, you'll have this magnitude, right? Then you got to divide by the 3/2 power of x squared plus y squared. The first power of x squared plus y squared because of the inverse square law, the square root because you have to make this into a unit vector. So there's your expression for the force at xy due to this charge at the origin on this charge here. In general, that would be we could write this as K, Chalk's misbehaving, KQ1, Q2 over x squared plus y squared to the 3/2 times the vector xi plus yj. Same expression I had here, except that now if I have different Q1 and Q2, I won't be able to use the specific value of KQ1, Q2 that we get for these two charges.